Hi everyone. Today we will be beginning our unit on quadratic equations and quadratic functions. We'll begin with 9.2, which is solving quadratic equations by factoring. Before we jump into that, I want to start with this warm-up. Let's go ahead and factor the quadratic trinomial x squared minus 12x plus 20 and the quadratic trinomial y squared minus y minus 42. Take a moment and go ahead and factor those. For number 1, we're looking for factors of positive 20 that add to negative 12. Those factors are negative 10 and negative 2. So this factors to the quantities x minus 10 times the quantity x minus 2. For number 2, we're looking for factors of negative 42 that add to negative 1. Those factors are negative 7 and negative 6. And so we get the factored form y minus 7 times the quantity y minus 6. So something to think about. What if this product of any two numbers is equal to 0? If we were to say two numbers times each other is equal to 0, what must be true about one of those numbers? So something times another thing equals 0. What can you tell me about those numbers? Take a moment and think about it and write your answer below. If the product of two numbers is equal to 0, that tells me that at least one of those must be 0. Right? Anything times 0 or 0 times anything is equal to 0. That product is 0. Okay, so now let's generalize. Instead of saying a product of two numbers, we'll just say the product of two quantities, A and B. So if the product of A and B is equal to 0, what can you tell me about the value of A, the value of B, or both? Well, a similar answer. That tells us that at least A or B has to be equal to 0. So either A equals 0 or B equals 0. Right? If A is equal to 0, well, then we have 0 times B is equal to 0, and 0 times B is just 0, so that's true. If B is equal to 0, then we have A times 0 equals 0, and A times 0 is equal to 0. Okay? So how can we use that information from questions 1 and 2 to solve the equation the quantity x minus 3 times the quantity x plus 5 equals 0? Can we solve for x here? Take a moment and look at this. Here we have a grouping, x minus 3, times another grouping, x plus 5, and that product is equal to 0. So similar to questions 1 and 2, yes, we can solve for x. We can do so by setting each factor equal to 0, and then by solving. Right? So if we set each factor, in this case, each factor would be like x minus 3 is a factor, and then we have x plus 5 is another factor. If we set each of these equal to 0, we can solve these linear equations. So x minus 3, to solve that, we add 3 to both sides, and we get x is equal to 3. On the other hand, x plus 5 is equal to 0. To solve this, we subtract 5 from both sides, and we get x is equal to negative 5. Now, in between these answers, we can put two things. We could either put and, or we could put or. And we have to consider which of these makes more sense in this context. Here we have x equals 3 or x equals negative 5. Because these are both solutions to this equation, right? If I were to plug in 3 in here, and actually, let's go ahead and do that. If I were to plug in 3 into the original equation, I would have 3 minus 3 and 3 plus 5. We would get 0 times 8 is equal to 0. And of course, 0 is equal to 0. So 3 is a solution. And if we were to check negative 5, right, plug in negative 5 in for x and evaluate the left-hand side, we get negative 8 times 0. And is that equal to 0? Yes, it is. So in fact, both of these x equals 3 and x equals 5 are solutions to this equation. So we have to consider, are we saying x equals 3 and x equals negative 5, or x equals 3 or x equals negative 5? The answer is or, because x cannot be equaling two distinct values simultaneously. We can't have x equal to 3 and x equals negative 5 because negative 3 and negative 5 are different solutions. It cannot be both of those quantities simultaneously. So it's one or the other. All right? So this property here, where if we have a product that equals 0, that means one of those factors must be 0, is called the zero product property. I'll often refer to this as ZPP, for zero product property. And it states that if A times B is equal to 0, if you have a product equaling 0, then at least one of the factors is equal to 0. So either A equals 0 or B equals 0, or both. In plain language, a product of factors is equal to 0 if and only if at least one of its factors is 0. Okay? A product of factors is equal to 0 if and only if at least one of its factors is 0. Now, in math, anytime you see this statement here, if and only if, you can think of that as a bidirectional statement. So I'm going to use like a double-sided arrow for that. And what that means is that this statement is true going either way. So a product is 0 if at least one of the factors is 0, and if one of the factors is 0, then the product must be 0. Okay, so this goes both ways. All right, so let's go ahead and use the zero product property to solve these equations. So here we have the quantity p plus 6 times the quantity p minus 4. This is equal to 0. So we can set each of the factors equal to 0. We're going to separate each of our equations by or. Now we can solve both of these equations. Subtracting 6 from the left-hand equation, we get p is equal to negative 6. And then for the right-hand equation, if we add 4 to both sides, we get p is equal to positive 4. So we get our two solutions. P is equal to negative 6 or p equals 4. In number 2, notice we still have something times another thing equals 0, so we can set each of those factors equal to 0, where the first factor is 5z and the second factor is z plus 10. Solving each of these equations, so on the left-hand equation, dividing both sides by 5, we get z is equal to 0. For the right-hand equation, subtracting 10 from both sides, we get z is equal to negative 10. All right. So now let's take a look at the steps for solving quadratic trinomials in standard form. So the first thing that we have to do is set the equation equal to 0. In order to use the zero product property, it must be equal to 0. So in the example, r squared minus 2r is equal to 3. I'm going to subtract 3 from both sides to get the equation equal to 0. So I get r squared minus 2r minus 3 is equal to 0. Step 2 is to factor. So I'm looking for factors of negative 3 that add to negative 2. The answer is negative 3 and positive 1. So we can factor that quadratic trinomial into its factored form, r minus 3 times a quantity r plus 1. Now, using the zero product property, I'm going to set each of those factors equal to 0. So we have the two equations, r minus 3 equals 0 or r plus 1 equals 0. Solving the first equation, the left-hand equation, I'm going to add 3 to both sides, and we get r is equal to 3. For the other equation, we're going to subtract 1 from both sides, and we get the solution r is equal to negative 1. All right. This is a quadratic trinomial, and you might remember from our last unit on polynomials, a quadratic is degree 2, a polynomial of degree 2. In general, these quadratics will have at most 2 solutions. And in general, for all polynomials, the number of solutions to an nth degree polynomial is at most n. All right, let's go ahead and practice. So solving these equations by factoring. Step 1, 3a, we have to set it equal to 0. So I'm going to add 40 to both sides. And we get b squared plus 13b plus 40 is equal to 0. We're looking for factors of 40 that add up to 13. The answer, positive 8 and positive 5. So we have the quantities b plus 8 times the quantity b plus 5. Now using the zero product property, I'm going to set each of those factors equal to 0. And now we can solve each of those equations. So in the first equation, I'm going to subtract 8 from both sides. We get b is equal to negative 8. In the other equation, I'm going to subtract 5 from both sides, and we get b is equal to negative 5. 3b, it's already equal to 0, so we can just go ahead and factor. So this, I notice there's a greatest common factor of q, so what's left inside is q plus 20. So we have q times the quantity q plus 20, and that's all equal to 0. Now, because it's in factored form, we can use the zero product property to set each factor equal to 0, and then solve. The left-hand factor, we have q equals 0. That's already solved. For the right-hand equation, we subtract 20 from both sides, and we get q is equal to negative 20. So our two solutions, q equals 0 or q equals negative 20. Let's go ahead and try 3c. So here we have, it's already equal to 0, so factors of negative 18 that add to negative 3. The answer, negative 6 and positive 3. So v minus 6 times the quantity v plus 3 equals 0. Zero product property, we're going to set each factor equal to 0. In the left-hand equation, adding 6 to both sides, we get v is equal to 6. In the right-hand equation, subtracting 3 from both sides, we get v is equal to negative 3. And last but not least, 3d, we have this is not equal to 0. So to get it equal to 0, I'm going to add 7n to both sides. So we get n squared plus 9n plus 20 is now equal to 0. Factors of 20 that add to 9, the answer, positive 5 and positive 4. So now, using the zero product property, I can set each factor equal to 0. And so I have n plus 5 equals 0 or n plus 4 equals 0. For the first equation, subtracting 5 from both sides, I get n is equal to negative 5. In the other equation, I can subtract 4 from both sides, and I get n is equal to negative 4. All right, let's try an area problem. Number 4. A rectangle has dimensions x plus 7 and x minus 2, as shown below. Determine the value of x that gives an area of 36 feet squared. So I know that the formula to find the area of a rectangle is equal to its length times the width. So I know that the area is equal to 36 square feet. And I know that the length of this rectangle is represented as x plus 7. And I know the width is represented as x minus 2. You might have flipped those around. That's totally fine too. We're taking the product. So now I'm going to go ahead and multiply those two binomials, x plus 7 and x minus 2. And I get x squared minus 2x plus 7x minus 14. And that's all equal to 36. I'm going to combine like terms on the right-hand side of the equation, x squared plus 5x minus 14. And that's all equal to 36. Now I need to set this equal to 0, so I'm going to subtract 36 from both sides. I get 0 is equal to positive 5x minus 50. Okay, now we're ready to factor. So in order to use the zero product property, we need to factor this trinomial. So factors of negative 50 that add to positive 5, the answer is x plus 10, positive 10, and x minus 5, negative 5. Okay, so here's the factored form of that quadratic trinomial. I'm going to move over here for a little bit more space. Now using the zero product property, I can set each factor equal to 0. And so I get x plus 10 equals 0 or x minus 5 is equal to 0. On the left-hand equation, I'm going to go ahead and subtract 10 from both sides, and I get x is equal to negative 10. On the right-hand equation, I add 5 to both sides, and I get x is equal to 5. Now, we have two solutions, but we have to consider what the context of this scenario is. We're looking at dimensions for a rectangle. If we were to plug in x equals negative 10 into either of these dimensions, we'll notice that that dimension becomes negative. If you plug in negative 10 here, we get negative 10 plus 7, which is negative 3. And likewise, if we were to plug it in for the width, negative 10 minus 2 is negative 12. We would get that the length or the width is a negative distance, which doesn't make a whole lot of sense. I can't really say that this rectangle has a length of negative 3 feet or negative 12 feet, right? That doesn't make a whole lot of sense contextually. So we eliminate the solution that causes the dimension to be negative. We also should check x equals 5 to see if that causes any dimension to be negative, and indeed it does not. So if we plug in 5 into either of these dimensions, we get a length of 12 and a width of 3. And so that checks out. Okay? So our solution is just the single answer, x is equal to 5 feet. Okay? So we eliminate, just in summary, x equals negative 10 because we can't have a negative length or width. Can't have a negative dimension. All right? So in summary, the zero product property, we're going to set each equation, set the equation equal to 0. We're going to get a quadratic. We're going to factor that quadratic, or rewrite it in factored form. And then using the zero product property, we can set each factor equal to 0 and solve. All right? There's one more page. Go ahead and try the practice problems on the final page of our notes. Pause the video, and then come back to check your work. All right. Let's go ahead and check our work. So number 1, solutions k equals 4 and k equals negative 3. Number 2, negative 3 or negative 4. Number 3, here we have a fraction as an answer. We get negative 2 and negative 6/7. Number 4, don't forget to set it equal to 0 first, and then factor. We should have 2 solutions, h equals 0 and 1/3. I should say, or 1/3. Number 5, we get solutions 3 or negative 1. Number 6, 8 or negative 5. Number 7, negative 4 or negative 2. And finally, 8 is already factored. We get solution 0 or 5/2. Did you get all of them? We're going to get a whole lot of practice on solving quadratic equations by factoring. All right, we'll see you tomorrow in class. Have a great day, everybody. Goodbye.